Also, if you have any questions, please come to the microphone, or if the speaker could repeat the question, or those that are streaming, and then whenever you're ready.
Good afternoon, everyone. Thomas Alt. I guess I have to disappoint everyone in the room. By now, every one of you should have seen parts of the presentation. So that being said, if you guys are bored, please leave. If not, I will just run through the slides and hopefully we have a fruitful discussion. Optimized AR delivering the augmented city. What is the core problem in Mateo's view of augmented reality? If we are all very honest about the field, we should realize that augmented reality, especially on mobile devices, is in terms of the user experience not quite there yet. And everything I will be talking about is how do we make augmented reality right on a level that everybody wants to use it on a daily level. I'll run through this. Who is Metaio? Just a quick introduction. We are in the space forever. I actually started in augmented reality when I still had hair. If you look at my hair right now, you only see reflections. This is how long I've been in augmented reality. Company was bootstrapped out of a research project we conducted in Europe. Today, Metaio is serving the augmented reality ecosystem with 500 B2B customers, and we are most famous for our SDKs, so basically the delivery platform for many applications of augmented reality. As a mission statement, we said by 2014, AR will be on every smartphone. For engineers, that's kind of a bold statement, pretty much triggered around the fact that we believe that the smartphone or tablet, for that matter, is the right device for augmented reality. So I talked a little bit about the mass consumer adoption of augmented reality on mobile devices previously. What, in our view, drives it is the usefulness. So looking at our company's background, where we started off, we really started in industrial augmented reality, which pretty much solved needs of engineers in the industrial domain. Now, barely 10 years later, we are coming back to that and saying, okay, the usefulness, so having singular use cases supported and solved by augmented reality is back to the augmented reality developer network. So how do we get usefulness for augmented reality? In our view, it's very much great technology combined with great content. And it sounds like a very cool marketing statement, and our Marcom guy, Drake Lord, would have said it the exact same way. What I'm trying to put behind the statement is a little bit of color, what we actually mean with the statement, great content plus great technology. So, but before I come to that, Lisa Murphy from the team showed it yesterday. I'll show you, in my view, very useful augmented reality application, which is solving a need of the customer. We launched that in Europe for new customers of the fine Audi A1 product. It's a pretty small car. You won't see it here in the suburban-driven automotive world, I guess. But it's a small car from Audi. What the application does, it pretty much diminishes the need of having a printed out manual for the car. The way the application works is you start the application, you sit inside your car. 5 types of image processing technologies are running in parallel. And what these 5 types of technologies essentially do is they detect arbitrary objects in the inside of the car. And once something is detected, it pushes the manual section of the functionality to the end consumer. Just talking about the computer vision side of things, what you need in there is basically OCR, you need markerless 2D tracking, you need markerless 3D tracking, you need edge tracking, all combined and fused together to solve this essentially very, very hard problem. Problems like you have 70 different warning lights in the instrument cluster, and the application has to be ready to basically see all of them and connect them. Very useful application. I would like to welcome Danica Berlin from our team. She's sitting over here. When Danica was still working in Germany, she did a movie and she pretty much envisioned how her life would B, the fully integrated augmented reality. Danica likes to watch movies a lot, so what you see in the first part of the movie is also a very useful case. Danica likes to watch movies, but she has no clue how to connect her VCR. So what we show in the movie here is basically how Danica is told how to connect the VCR. Back then, Danica was actually dating a guy named Gunnar, and this Gunnar guy, he's very much into cars and online shopping for cars. So he's using the same set of technologies to detect rims on his car, on his Audi product, and superimpose what he can buy with that. And the story goes on and on. Basically, these are all little use cases which are wrapped around in individual apps and can be used from people. I'll let Danica finish with her email and skip to the next use case. Bruno Osan from Total Immersion, actually in his keynote yesterday, talked a little bit about how he doesn't believe in the print use case of augmented reality. In my view, he's right that it's kind of like a wacky idea that you have a printed out magazine and you mix it with content on augmented reality. And I, to be honest with you, didn't believe in the use case at first either. Because it was kind of, like I said, a wacky idea. You hold your magazine, you hold your camera on it, you see content on it. Fact is, though, that every month in Germany only, there are 10 million magazines delivered to end consumers with content on augmented reality or with augmented reality content. And people actually do use it. And they also consecutively use it. So we can actually measure what is done in the background. A lot of people come back to the experience and see new content. What is the content they are actually viewing? It's not what the augmented reality researchers had thought it would be. No fancy 3D models, no anything. It's more simple overlay of 2D videos onto your real world. And you can see some of the titles here. So to empower this content-driven network, we have introduced, and I'm not going to get it too salesy here, but we have introduced our new product, the Metaio Creator, which will facilitate this content pipeline. And this content pipeline is, in my view, very important. If you look on the development, how the web has developed, it's very important that you have easy tools to pretty much curate and upload content to augmented reality experiences. This was the boring part, the content-driven part. I'm coming back to the mission statement. Usefulness equals great content plus great technology. Being an engineer by education, at least, I'm feeling much better to talk about the technology behind augmented reality. So in my second part, I will concentrate on this. The good news is, if you look around at ARE2012, you have a lot of people from the chipset industry here. Actually, the speaker after me from Freescale will talk about what he thinks is needed in augmented reality. We have discovered the space of hardware-optimized augmented reality roughly a year ago by realizing, like I said in the beginning, the user experience, especially for mobile augmented reality systems, are not quite there. So what we are doing internally, we are taking our core SDKs and we are optimizing them together with partners to have less power consumption and higher fidelity in terms of frame rates on the device and more tracking stability. In the middle, we have the SDKs provided to the people, and then we have the content delivery network, like I said, and we have the users for our own platform, the Juneo augmented reality browser. Now it's getting a little bit more technical, so I don't think Lisa has shown the slide, has she? So I will elaborate a little bit more. If you look at how computer vision-based augmented reality is done on mobile devices, it's actually shown in this map right here. So we start with image capture. We take the sensor input, we do pre-processing, and then the real computer vision stuff starts. The feature tracking, feature extraction, descriptor building, matching, and then last but not least, the pose estimation. And then we are shifting to the GPU, where we're doing the rendering of the 3D objects. This pipeline is essentially the same if you do it on mobile, if you do it on PC, if you do it on web. And the big question, or the big secret is now, what do you optimize on hardware that is general enough to really speed up the process. We have done first experiments, and we're working with the semiconductor companies, in our view, to really go about and take the basic things like feature tracking, feature extraction, building feature descriptors, and analyze how to accelerate them, will create an Apple-like user experience for augmented reality. And this is part of what we're looking at. At the same time, I mean, there was much talk about the mobile AR market. I'm actually in high hopes for the market. This is the first time we're showing these figures. We have released our own mobile SDK, free mobile SDK, a couple of months ago, and we have generated in 3 months only 10,000 downloads for the SDK. We have more than 1,000 active developers and 200 published applications. It's pretty big. I know that on the App Store there are 300,000 apps out there, but if you look at the developer ecosystem, which is even able to develop 1,000 applications which are using our SDKs plus the other SDKs which are out there, I think this is a great success number. So what do we have to do more on the technical level? We have to work, and everyone who's in the space have to work on making the tracking problem better, and I talked a little bit about hardware optimization. This is actually a benchmark, an internal benchmark we're doing on our system every night. So basically, while we're developing the core algorithms, computer vision algorithms, we benchmark these algorithms against the database of 48,000 images automatically every night. And this continuous improvement is shown if you just take a snapshot from the results, and there are 3 criteria: the ratio of images tracked, the time needed per tracking per image, and the improvements in decrease of the reprojection error, so the accuracy of the actual computer vision algorithms. And I just took a snapshot from the database before I left Germany, and if you look at the time frame from 1st of March, we have achieved 14% better ratio, 10 milliseconds per image faster, and 5 degrees accuracy improvement. But still, we are not there. This is just a snapshot from the database, but this shows you that augmented reality conceptually is there. You just have to engineer it and make it more robust. I'll wrap up here. I'll have 1 more minute left. Just talking about the augmented cities, we actually won the Augis Award. By the way, my personal opinion, the coolest demo I've seen at the Augis Award was the Sony demo. And keep in mind, talking about hardware optimizations, what they said good augmented reality runs not at 30 frames per second on a smartphone, which is what we're seeing right now. They said it runs at 60 frames per second, or 60 hertz actually. And this is where the whole hardware optimization can go to. Still, I want to share the movie from last night one more time, because I actually think it's groundbreaking, and it's also a very positive statement for the developer ecosystem in my view. This is what we have, we all have basically, GPS, POI-based augmented reality. No good experience at all, and no end user will use it on a day-to-day level if the overlay of the virtual information is jittering around somewhere in your real environment. And you can see this in here, and this at least motivated me a lot, how you can improve this result if you fuse it together with computer vision. And in this case, we have a silhouette shape of the building. We find correspondences from the live video image and from the model, and we have it snap in onto the real building. The resulting augmentations are not made by a designer, but I think they very nicely show the direction where this whole technology can go in. And this is not a fake movie. I mean, in augmented reality, we're in the demo business, but not necessarily in the fake business, right? This is an actual live footage from the device itself. And I guess as a last slide, it should motivate everyone to keep on working and keep on believing in augmented reality. reality. I can't do anything else in my life anymore anyhow, so I have to believe in it, I guess. To finish up, we talked to Ori, and Ori is obviously a big fan of ours, and so are we of Ori. And we basically have two conferences. One is in the US, where I'm standing right now. We also have one in Munich. The legendary visit to the Oktoberfest. Track actually knows what I'm talking about. So please be invited to our conference Inside AR, which we are actually hosting with an Oktoberfest visit at October 1st and 2nd. Thank you very much.
So as we get set up for the next speaker, any questions?
Yeah.
What needs to happen on a global atmosphere to get to that 60 FPS side? Is it mainly just faster cores, better cameras?
Yeah. So the question, what really has to happen on the mobile side to make the experience better? You actually answered your own question. It's right. So sensor capture is very important. Sensor synchronization is very important. Of course, camera quality and camera speeds is very important. And then basically the feature maps itself, which you're tracking against, have to be more accurate. And these are the three big building blocks. Beyond, there are many smaller things you can do, auto calibration of the lens itself, and other optimizations you can do. These are all things you can engineer, not necessarily invent. And that's different from a couple of years ago.
I was wondering, what is your R&D team working on?
So the question was, what is my R&D team working on? Track, you want to answer?
Sure.
No, I was kidding. So really, obviously, it's it's undisclosed to a certain degree. The overall focus for this year is, of course, just making the experience better. So gradually improvements in terms of what we have right now: 2D markerless tracking, 3D object tracking, which we have just released in the SDK, and to make this really good. Essentially, I guess, and I guess you would agree, the big things have been invented. Now they have to be engineered to a certain degree.
A lot of your comments regarding optimization kind of relied on the camera. Looking at GPUs, like Imagination Technology and the cores, do you see any optimizations coming from being able to stream textures better in that type of way? Because the GPU technologies come a long way outside of just camera technology. Any response? Because in your marketing case, you talked about how the majority of people in the print ads are looking at video. So I'm wondering if you're doing more and more to push the video textures and streaming in that area.
Actually, yes. One issue we have in augmented reality in general is that the pipeline relies on the CPU and the GPU, right? The computer vision side is mostly running on the CPU, while the rendering part is running on the GPU. Mobile rendering is very much limited. We have, for the mobile system, we have our own rendering core, and we are optimizing that especially into this direction of better streaming video textures into a 3D view, taking higher poly count models into consideration, and so on and so forth. To answer, I'm thinking you have an additional answer. How much of the computer vision pipeline can you do on the GPU? In my view, you want to have better rendering results at the same time, so the focus of the hardware optimization should be on the CPU.
So just to clarify, so you have your own software renderer?
Yeah.
Also?
Yeah.
So it's a proprietary, or is that available in your SDK also?
It's available in the SDK in binary form, of course, but it sits on top OpenGL, yes.
Okay, thank you.
My question is similar to his. You showed the video of the GPS and the video tracking. Are you guys looking to
implemented software that's publicly available that integrates GPS and that video tracking?
Yes, and we actually have it available. If you download the SDK, it has parts in it. It's one of the tracking methodologies you can use as either GPS or you can do the vision-based part of it. What we have released at a research conference last year, and it's, in my view, a nice view on sensor fusion, is what we call gravity-aware feature descriptors, where we at a very low level integrate the rotational sensor values with the feature descriptors to basically associate to every visible point in the image its direction to the Earth coordinate system. Okay, and by this, and it's a nice example on how you very tightly can combine those. On the API level, you can combine them anyhow.
Okay.
Yeah.
Well, no more questions, so thanks a lot, Tom.
Thank you.